Hi everyone, and welcome to our video on using SOH CAH TOA along with our addition and subtraction formulas for sine and cosine, and then also tangent, but we'll show tangent in a special way. So in these problems, what we want to do is eventually use our formulas for these parts. So that will be step two. Step two. First thing we really do though is we make a right triangle with this information. I'm going to use blue for that. And also with the other. Okay, so let's use purple for that one. Okay, so these in the blue and the purple are really the first steps. So step 1 and 2 here. Well, really, I guess step 1 and 1. I'm going to label them both 1. Okay, so step 1 is to do SOH CAH TOA with those pieces of information. Okay, so if we have sine of alpha equaling 4/5, I'm just going to make my right triangle. So here's alpha. And then opposite over hypotenuse. And then we could do Pythagorean's theorem to get this missing side. Well, you might also notice this is a special right triangle. It will be 3. Okay, so I'll keep it blue, but you could do Pythagoreans, or you could hopefully recognize that it's a triple, Pythagorean triple, 3, 4, 5 right triangle. Okay, so but we did need it regardless, so we do have it now. And then what I like to do, just right to the side here, I'm going to write sine of alpha equals 4/5. And then cosine of alpha equals 3/5. But then we go back and say, well, they did say it was in quadrant 2. So then we've got the sine of alpha should stay positive. The cosine should be negative. Okay, and it might help to just label quadrant 2 next to the triangle to see it. And that's all we're going to need out of these. So we just want sines and cosines. And then our other step 1 is still SOH CAH TOA. It's just with different information. So I'm just drawing a generic right triangle with angle, now that's beta, the B looking thing, beta. And then we've got cosine of beta is adjacent 5/13. That's right there. Okay, and then with this, again, we can use Pythagorean's theorem to get the missing side. This is a special case again, though. It is 12. So on this problem, they're being nice to us with these numbers, but we can always set up Pythagorean's theorem to get a missing side. I'm just skipping that step to show the full Pythagorean theorem to save a little time on this problem. Okay, but just like above, now I'd say, well, let's get our sine of the beta and cosine of beta ready. Now we already know cosine of beta is 5/13. They said so. And then they say, well, we're in quadrant 4 though. So when we set up our sine, it would be 12/13. But in quadrant 4, that makes it negative. Okay, and just like before, it might help to just label quadrant 4 somewhere to make sure our signs are good. Okay, so there's the true first step in this. Now that we've got our right triangles, we go back to our step 2, or back to the start where I labeled step 2, and we want to use our formulas. Okay, so it's addition or subtraction formulas. So on these problems, or on this problem, it would be addition because we see they're all pluses there. Okay, so we're going to do cosine of alpha plus beta. And then we'll just set up our formula. It is cosine of alpha, cosine of beta, and then minus sine of alpha, sine of beta. Okay, so I always remember cosine, you want cosine, cosine, sine, sine, and then switch the sign in the middle. So the plus here became a minus in there. And then now we'll just substitute all these in. All right, so let me use the colors again. So we have cosine of alpha and sine of alpha right there. And then we have cosine of beta and sine of beta right there. And we'll just sub in what we have as their actual values. Okay, so cosine of alpha, they say is negative 3/5. So again, I'm just using it. Let me use the blue parentheses on that part. Let's set those up also. So I'm just subbing these in that I'm now starring directly into the equation. Let's go ahead and do the sine of alpha as well. So that's they said it's 4/5. Okay, so I'm just subbing those in. We'll even change the color. There we go. Okay, and then in the purple, We've got cosine of beta, so that's down there, is 5/13. And then let's put the minus, and then sine of beta is negative 12/13. Okay, and then after this, it's now just simplify. Okay, so we've got negative 15 over 65, and then minus a negative would become plus 48 over 65. And then to save some room, I'm going to put my final answer right here. Our cosine of alpha plus beta is, okay, so combining this, we get 33 over 65. Okay, so that's our cosine of alpha plus beta answer. So it's a substitution and then simplify. Now let's set up the sine of alpha plus beta. Okay, so same deal, I just want to get the formula first. So we've got sine of alpha, cosine of beta, and then plus sine of beta, cosine of alpha. Okay, and then like the last problem, we'll just sub those in. Okay, so we've got, I'll keep it in blue. So sine of alpha, we're saying is just 4/5. And then let's keep the alpha in blue. Cosine of alpha is negative 3/5. So I'm just subbing things in now to make it a little easier on me with the color change. Okay, and then cosine of beta and sine of beta, that's our purple triangle down there. Cosine of beta, they said, is 5/13. And then we've got plus sine of beta is negative 12/13. Like that. Okay, so there's the big setup, and we're running a little low on room, so I will just say let's simplify and put our final answer right here next to it. So it would be 20 plus 36 up top, so that would be 56, and then over 65. Okay, so it's just simplifying that fraction there. And then now the last one. So I'm going to scroll just a little bit. We can see the next problem that's coming, but tangent of alpha plus beta. Okay, so tangent of addition formula or subtraction formula can look pretty wild. However, a lot of times we just need to go back and remind ourselves that tangent is sine over cosine. So we're going to do sine of alpha plus beta over cosine of alpha plus beta. And then we have those two answers. So sine of alpha plus beta was the 56 over 65. The cosine of alpha plus beta was the 33 over 65. And then like always with tangent, once we set up the sine over cosine part, the denominators there would cancel, and it looks like we're left with 56 over 33. Okay, so tangent isn't bad at all once you have sines and cosines, and that's always true for all trig functions. Once you have sine and cosine, you usually roll in afterwards. Okay, so sorry I got a little crowded down there, but we've got all of the problem now solved for. So that's it. So SOH CAH TOA and then use those formulas. So really, whenever you see any special type of angle now, like these, addition, and there's others coming, we just want to instantly get a formula in our head and then use it eventually. So here we used it in our second step. Okay, so thanks for watching. If you have any questions, please let me know.